Hello everyone, we are discussing chapter number 5, periodic classification of elements. Today we are taking next topic, making order out of chaos, Mendeleev periodic table. When there is a failure of Newton's law of octet, scientists continue their work on finding a pattern in which they can correlate the properties of elements with the atomic mass of elements. Main credit for classifying the elements goes to Dmitry Ivanovich Mendeleev. He was a Russian chemist. He was most important contributor for classifying the elements or arranging them in the periodic table form. He arranged the elements on the basis of fundamental properties, atomic masses and similarities of chemical properties between the elements. When Mendeleev started his work, only 63 elements were known, and he is able to find out the relationship between the atomic masses of the elements and their physical and chemical properties. Among the chemical properties, he contributed or started or concentrated his work with the elements hydrogen and oxygen, because these elements hydrogen and oxygen are very reactive and they form maximum variety of the compounds with other elements. So as a basic property of his arrangement of the element in the form of a table, we can say Mendeleev periodic table, formula of hydrides and oxides are taken as basic property. When Mendeleev started his work, 63 elements were known at that time. He took certain cards and note down the property of one element on each card. Then he take those cards and place it or pinned it on the wall one by one, and there is a definite pattern in which periodic recurrence of the physical and chemical properties was observed. Means there is a definite pattern after which certain elements were repeated and repeated again, whose property matched with the other elements. And on this basis, he formulated Mendeleev periodic law, which states that properties of elements are periodic functions of their atomic masses. Mendeleev periodic table consists of vertical columns called groups and horizontal rows known as periods.
Merits of Mendeleev periodic table. It made the study of elements simple and systematic. It is based upon fundamental property of an element, that is atomic weight. It helped in the correction of wrong atomic weights. Example, the atomic weight of gold and platinum were corrected here. Some gaps were left in this periodic table for undiscovered elements. This accelerated the discovery of these elements. Example, gallium, germanium, etc. Further, Mendeleev left some gaps in his periodic table. Instead of looking upon these gaps as defects, Mendeleev boldly predicted the existence of some elements that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral eka, means 1, to the name of preceding element in the same group. For instance, scandium, gallium, and germanium, discovered later, have properties similar to eka boron, eka aluminium, and eka silicon respectively. The properties of eka aluminium predicted by Mendeleev and those of element gallium, which was discovered later and replaced eka gallium and listed in the table which is in front of us, that is table 5.5. As we can see, atomic masses of eka aluminium and gallium are given here, and the formula of oxides and chlorides are given. It is clear from this table that valency of eka aluminium in its formula is 3 and that of gallium is also 3. This provides convincing evidence for both the correctness and usefulness of Mendeleev's periodic table. Further, it was the extraordinary success of Mendeleev's prediction that led chemists not only to accept his periodic table but also recognize him as the originator of the concept on which it is based. Essential features of Mendeleev's periodic table as it is based on Mendeleev's periodic law. Vertical columns are called groups and there are 8 groups, that is group 1 to group 8. Group 1 to group 7 are subdivided into two subgroups A and B. The elements in a subgroup or group 8 have similar properties. The horizontal rows are called periods. In a period, properties of an element gradually changes from metallic to non-metallic on moving from left to right. There are some gaps in the periodic table because these elements were not discovered at that time. Limitations of Mendeleev's classification. Electronic configuration of hydrogen resembles that of alkali metals. Like alkali metals, hydrogen combines with halogens, oxygen, and sulfur to form compounds. On the other hand, just like halogens, hydrogen also exists as diatomic molecule and it combines with metals and non-metals to form covalent compounds. Position of hydrogen. Hydrogen was not given a definite position because it resembles group 1A and group 7A. Position of isotopes could not be explained. On the basis of atomic weights, different isotopes of an element should be given different places, but there is no place for isotopes of an element in this table. Example, hydrogen has 3 isotopes, protium, deuterium and tritium, but only one position was given to hydrogen. Separation of chemically similar elements. Some chemically similar elements such as gold and platinum has been separated. No relationship between electronic arrangement. Grouping of chemically dissimilar elements, for example, copper, silver and gold have been grouped with lithium, sodium, etc. from which they are quite different. It cannot explain the cause of periodicity of the elements. Atomic masses do not increase in a regular manner in going from one element to next. Thank you.